Hello friends, welcome to BSR Studies. I am Bala. Yesterday we have completed traditional units and dimensional quantities. So I will explain dimensional quantities again. In dimensional quantities there are four quantities. M mass, L length, T time, K temperature. K is nothing but Kelvin. So on basis of dimensional quantities, how will we write dimensional formulas? Dimensional formulas. So if I take speed formula is length by time. Speed formula is length by time. So the units of length is meter and unit of time is second. In this there is no mass. In unit there is no mass. So the dimensional formula speed is, there is no mass, so 0, m0. Length is 1 unit is there, length, so 1. Time is there, time 1 unit is there, but the time is in denominator, so t minus 1. Or else we can write 1 by T1. If I take force, I am taking force. Force formula is mass into acceleration. So in this acceleration unit is meter per second square and mass is kg. So kg meter per second square is the unit. This unit is also written as Newton. Okay, the dimensional formula of force is, there is one mass, 1 unit of mass, so m1, 1 unit of length, l1, 2 units of time, but time is in denominator, so t minus 2. Okay, note down. So today's topic is rules for writing a unit. Today's topic is rules for writing a unit. In this first rule is, all units and their symbols is, all units and their symbols we have to write with small letters. All units and the symbols we have to write in small letters. If you see, for example, gram, small letter, and G, unit. So this is the correct method. And meter, M, small letter. So this is the correct method. If I write capital G, gram, this is wrong. We should not write like this. And capital M, meter, we should not write like this. Okay, we should write small letters, unit and a symbol. Okay. So second rule, if any unit comes from scientist, the scientist name should written in small letters. Scientist name is written in small letters and symbol is written in capital letters. Scientist name should written in small letters and the symbol of scientist name is in capital letters. Okay. If a example, Newton, it is a scientist name, so unit is N. It is correct or not? It is not. not correct, because name should be in small letters. This is the correct method. Newton, capital N symbol. This is the correct method. So another example. Joule, J. This is correct or not? This is not correct. So in this capital letter is there. So Joule, capital J, it is the correct method. Okay? Note down. So third rule. Third rule is there is no commas, full stops, hyphens, semicolons. There is no commas, full stop, hyphens, semicolons should not there. For example, if I take megagram, some students writing MEGA gram. In between they are putting hyphen. So this is not. This is correct. And gigagram. We should not like this. Gigagram. We should not keeping commas, full stops, hyphens should not there, and space bars like this. Okay. Fourth rule. From kilo, we already know that from kilo, mega, giga, tera. 3 units are there from kilo. These units are written in capital letters. We should write capital letters, not small letters. From kilo, mega, giga, tera, these units have to write with capital letters. This is the fourth rule. And the rules for writing unit is completed. What we will run? We should not write scientist name capital, and prefix between prefixes there is no any full stops, commas, hyphens, etc. And the next topic is length. Next topic is length. The distance between this point A and this point B. I am taking these 2 points. And the distance between these 2 points and draw a straight line. Distance between 2 points with a straight line is called length. If you take 3 full stops, and we have to join like this and like this, then the length between these triangle is, we should add AB plus BC plus CA. Okay. What is length? When 2 points are there and straight line we have to draw, and the length between A and B straight line is length. For example, if I take this is point C and straight line between this is point D, and the straight line between C and D point is 3 meters. So what is the length between C and D? 3 meters. I am asking that the length between C and D is 3 meters. And the length between this A, C, D, A, C, D. This is 3 meters, this is 2 meters, this is 2.5 meters. Then what is the length between triangle ADC? This is a triangle now. So what is the length between triangle ADC? So the length between triangle ADC is equals to sum of all sides. 3 meters plus 2 meters plus 2.5 7.5 meters. So what is the sum? 7.5 meters. This is the length of this triangle. Okay. Then what is the units of length? Units. We already know that there are 4 systems of units: SI, MKS, CGS, FPS. So the units of length in these 4 systems is SI meter, MKS meter, CGS centimeter, FPS foot. SI and MKS both have same units, and CGS is centimeter, FPS is foot. Okay, these are the units of length. In units, submultiples and multiples. In units, submultiples and multiples. In submultiples, we already know that 1 centimeter, 1 millimeter, 1 micrometer, 1 nanometer, 1 angstrom. These are all we know. So 1 centimeter is equals to 10 to the power of minus 2 meters, which is nothing but 1 by 100 meters. Okay, 1 centimeter is equals to 1 by 100 meters, and 1 millimeter is equals to 1 by 1000 meters, and 1 micrometer means 10 to the power of 6. Micro means 10 to the power of 6. So 1 micrometer is equals to 1 by 10 to the power of 6 meters, and 1 nanometer is equals to 1 by 10 to the power of 9 meters, and 1 angstrom is equals to 1 by 10 to the power of 10 meters. These are all we can write like this also: 10 to the power of minus 3 meters, 10 to the power of minus 6 meters, 10 to the power of minus 9 meters, 10 to the power of minus 10 meters. Okay? These are the submultiples of length. So what is the relation between angstrom and nanometer? The relation between angstrom and nanometer is, if I take 1 nanometer is equals to 10 to the power of minus 9 meters. So 1 meter is equals to how many angstroms? 1 meter, we already know that 1 angstrom is equals to 10 to the power of minus 10 meters. So this 10 to the power of minus 10 is transferred to this side. So 1 meter is equals to 10 to the power of 10 angstroms. So here we have to put and multiply 10 to the power of minus 9 into 10 to the power of 10 angstroms. So 10 to the power of minus 9. So product rule: minus 9 plus 10 angstroms. So here 1 nanometer is equals to 10 angstroms. This is the relation between nanometer and angstroms. Okay. So what is the relation between micrometer and angstrom? We already know that micrometer 10 to the power of minus 6 meters. So 1 micrometer is equals to 10 to the power of minus 6 meters, and 1 meter is equals to 10 to the power of 10 angstroms. We already know, into 10 to the power of 10 angstroms. Here 10 to the power of minus 6 product rule plus 10 angstroms. Here 10 to the power of 4. 10 minus 6, 4. So 10 to the power of 4 angstroms is the relation between angstroms and micrometer. So here what is relation? 1 micrometer is equals to 10 to the power of 4 angstroms. This is the relation between micrometer and angstroms. Okay. These are the submultiples of length. So multiples. We already know multiples: decameter, hectometer, kilometer, and megameter, gigameter, terameter. Okay, so 1 decameter is equals to 1 by 10 meters. Here 1 hectometer is equals to 1 by 100 meters. 1 kilometer is equals to 1 by 1000 meters. Inverse of 1 meter is equals to kilometer. We already know 1 meter is equals to 10 decameter. So they are asking 1 decameter. So 1 decameter is equals to 1 by 10 meter. Okay. So in 1 megameter, this is megameter. Megameter is equals to 10 to the power of 6 meters, and 1 gigameter is equals to 10 to the power of 9 meters, and 1 terameter 10 to the power of 10 to the power of 1 by 10 to the power of meters, 12 meters. 1 by 10 to the power of 12 meters. 1 terameter is equals to. Okay, these are the multiples of length. So the relation between angstroms and multiples. The relation between angstroms and multiples. I am asking the relation between angstrom and kilometer. We already know that 1 kilometer is equals to 10 to the power of 3 minus 3 meters. We already know 1 meter is equals to 10 to the power of 10 angstroms. So here 10 to the power of minus 3 into 10 to the power of 10 angstroms, and 10 to the power of minus 3 plus 10 angstroms. Here 10 minus 3 7. So 10 to the power of 7 angstroms. What is the relation between kilometer and angstroms? 1 kilometer is equals to 10 to the power of 7 angstroms. These are the submultiples and multiples of length. Okay? And the practical units of length. These are very important. And the practical units of length. What is the practical units of length? In this, first practical unit of length is AU. AU means astronomical unit. Astronomical unit. AU means astronomical unit. The AU is nothing but the distance between sun and earth. For example, I am taking this is as sun and this is as earth. The astronomical unit means the distance between earth and sun. What is the distance? We already know. 1.496 into 10 to the power of 15 meters. Okay. This is the first unit, practical unit of length, and the second unit. Second unit is light year. What is light year? If I take this is a sun and this is a earth again. So here the sun gives light. So this light comes with a speed of 3 into 10 to the power of 8 meter per second to earth. So they are asking what is light year. Light year is nothing but the distance between the time between sun and earth for giving light. So here 9.476 into 10 to the power of 9 is the light year. Okay, note down. So today's class is completed. మీకు నచ్చితే లైక్ చేయండి, షేర్ చేయండి, సబ్స్క్రైబ్ చేయండి. థ్యాంక్ యూ.